Hello there. This is a sample walkthrough about how your output should look for programming assignment number 5. On the left here, I have my client program, and on the right here, I have my server program. Now, yes, I am using idle to demo this. Don't get mad. So notice is that like the information such as the shared key that's being used for decrypting and encrypting stuff is just hard-coded here on both sides of the client and PY. So the client uses this key to encrypt, the server uses this key to decrypt here. We also have this shared secret, which is used in that MAC packet, and it's just hard-coded to be CSCI 466. I also have things like the port number also hard-coded, if you will, here on port 9090, okay? And I have some code, down here is redacted so you can't see it. So obviously, you want to start your server program first because it's going to be binding to a port, and then start listening for some messages here. Then, here on the left here, I'll start my client program, and the first thing it's going to do is ask for a message to send to the server. Okay, and so we're going to send this message to the server. The server is going to be able to authenticate and check the integrity of this message to see if it's been tampered with or corrupted or something like that. So I'm going to say hello, and remember that there's a 50% chance that this message, hello, is going to get corrupted or tampered with along the way here. It's a 50-50 chance, so we'll see if it happens. Okay, and in this case, it does not. So the client here computes the value of the hash, this is the MAC packet right here, of the message concatenated with S, and here is the SHA-256 digest. Over here on the server side, it received that message, and it printed out the encrypted message, it decrypted it, printed out the decrypted message, and then it's printed out the MAC that it received, the MAC being the hash of M plus S over here. Notice that this matches this, okay, received that same hash. Then the server is going to compute H of M plus S on its end and print it out. So here is what it computed on the receiving side, and these, the hash that it received and the hash it computed itself, match. So that's an indicator that the packet that it received did not get corrupted or tampered with, okay? So the hash is matched, so it's going to accept that packet. Now our program is still running, it should still loop, so now I'm going to give it another message to send. Okay, so I'm going to send the message Reese, and here we flip the coin, and now our message has been corrupted, tampered with, spoofed, whatever it might be. What does that mean? Well, you just need to somehow modify either or M or S. So what I did is I just took S and I shuffled it to kind of corrupt it. So either the message could have been flipped, or there could have been some intruder that does not know the shared secret, so the shared secret is going to be off. So when a packet's corrupted, all you need to do is just change something in M or S, or potentially both. That will ensure that this value right here will be different than what the server computes. Okay, so here is the MAC that it sent. So it's going to send the message Reese, followed by this H of M plus S. Here it is on the receiving side. Print out the encrypted message, the decrypted message, and then here is the MAC that it received, matches this guy over here, and when we compute H of M and S on our end, well, we're now going to get something totally different, so this hash and this hash do not match each other, so we reject this packet here, because over here, it got corrupted, so we sent kind of this corrupted packet over here. So when we run it on our end, we receive the original message and we append it with S, we get kind of the non-corrupted version here, okay? So how I handled it under the hood is I just corrupted S. I didn't do anything with M, okay? But you can do it on your side if you'd like. You can do it differently on your side if you like, okay? And that's how it should look, is you just kind of follow this similar format. Obviously, your hashes and your messages can be different. When you print out the encrypted message here, notice that it's actually printing out the bytes type, and that's okay. I had issues trying to decode this encrypted message into something readable or into UTF-8 encoded characters or ASCII characters, whatever it might be. So it's okay if your encrypted message is bytes or any type of text there. All right. That is going to do it. So good luck with that. Your programs are just going to keep running indefinitely and keep on looping there. All right. Good luck with stuff, and I'll see you later.